In this video, we are going to discuss about universal shift register. So, what is the register? Register is a collection of flip-flop, and shift register means it will shift either left or right. Universal means it will perform. Let me assume. If the value of S1 and S2, S0 is 0, 0, 0, 1, 1, 0 and 1, 1. Okay, so it is about to perform when the selection pin is 0, 0. This has to perform as whatever the input I have given, it should produce the output. Okay, so the output value is equal to input. Okay, so whenever it is 0, 1, the selection pin is 0, 1, it should right shift. This is a condition. Okay, we are fixing 1, 0 means left shift. For 1, 1, there is no change in the data. Okay, which means output will not reflect the change in the input. Okay, so these are the 4 conditions we are going to adapt in the universal shift register. So let me take that one as so this is your 4:1 mux. Okay, this is your 4:1 mux. So it has 2 selection pin, one is S1 and S0. Okay, so it has I0 I have fixed as a no change. Okay, this is your I0. Sorry, I0 is whatever the input that should be reflected at the output. Okay, so consider this is your D flip-flop and Q is your output, and it is having a common clock, right? Since it is a D flip-flop, it is having a common clock. Okay, so consider for I0, so you have 4 inputs, right? I0, I1, I2 and I3. So that value is nothing but I have given this I1, this is I2 and this should be I3. Okay, so whatever the input, so let me assume this one as, so here the whatever the input that will be reflected at the output, right? So if it is this S1 and S0 is 0, 0, I0 will be selected. So the I0 output goes to D. Okay, Y is your output, that will goes to D. So when the clock is active, D value will be reflected at the output. Okay, so let me assume this is E0, E1. Okay, or otherwise this is QA, QB, QC and QD. This is your output. So here whatever the input I am giving, that will be reflected at the output. So it is called as parallel in, parallel out. So these two condition is called as parallel in, parallel out. Okay. So next I'm going to explain the next one as let me take this color 1 1. Okay, so 1 1, what is the condition? Whatever the values I'm giving, it should not be reflected at the output. Okay, so I'm going to connect the same output to the so now I'm going to connect the let me change the color so I'm going to connect the output to the i3. Okay, so if that is the case, whatever the change in the input, it will not reflected at the output. Okay, so what I'm going to do is this type of connection I'm going to give it to the all the rest of the flip-flops, rest of the mux. Okay, so this is called as no change. Okay, the change in the input will not be reflected at the output. So the selection pin you have to give it as 1 1. Okay, so next what I'm going to do is I'm going to give 0 1. Okay, so for 0 1 for 0 1 for 0 1, what is 0 1? 0 1 is right shift. So I'm going to take I1 as your right shift value. Okay, so if any value I am giving, that will pass through the Y and it will reach the QA. Okay, so from QA this one. Okay, from in this way it will reach the value called I1. Okay, similar way, in similar manner, so it will reach I1. From I1 it will reach Y and Q. From Q it goes in this way. Okay, then it will reach I1 of this mux, then it will reach this way. Okay, and it will goes to I1. So this is called, so by in this way it will reach I3. So consider if initially the QA values QA, QB, QC values, QD values 1 0 0 0. So if I give the right shift value as 1, so 1, the 1 will goes here and this 1 will go here and this 0 will go here and this 0 will go here. So my output is 1 1 0 0. So this is my value. So initially it is 1 0 0. If I give 1, so this will shift here. Okay, so this is what you will obtain as answer. Okay, so next I'm going to give 1 0 1 0. So 1 0 means I'm going to do a left shift. So left shift means if I give So initially it is 100. Okay, so here if I give 1 at the left shift, so 0 will be shifted to 0 and 0 will left shifted, so I will get 1 0 0 0. So you can see from the left shift value, if I give 1, it goes to q, and from this value it will goes to the next mux i2, then y q, then it goes to the next mux i2 value. Since selection pin is 1 0, i2 gets selected, goes to y q, and it will goes to the next mux i2. Okay, so this is how it will do the left shift value. So let me see the mux selection. So initially when it is 0 0, it is PIPO, that is whatever the input that will be in the output. 0 1 right shift, 1 0 left shift, and 1 1 means no change in the data, that is output is equal to the input value. Okay.